Hello guys, welcome to DEY'S Learning. Our today's lesson is SNI reaction, that is nucleophilic substitution with internal return, or sometimes it can be defined as internal or intramolecular nucleophilic substitution reaction. Okay, let's start. If we consider the molecule S butan to all, that is this molecule, on treatment of this molecule with thionyl chloride, that is SOCl2, we have the molecule S2-chlorobutane. So this is actually SNI reaction. Now the problem is here the configuration of the chiral carbon is retained. If it would be SN2 reaction, then the configuration of this chiral center would be R, because in SN2 reaction the configuration is inverted, that is inversion of configuration, but here the configuration is retained. So this is not SN2 reaction, this is actually SNI reaction. In the similar way, if we treat the plus malic acid molecule, that is this molecule, if we treat this molecule by thionyl chloride, we will get the product plus chlorosuccinic acid. That is, the configuration of this chiral center is retained here. So this is another example of SNI reaction. Now we consider the mechanism of this reaction. In the first step, the lone pair of oxygen, the lone pair of the alcoholic oxygen attacks the sulfur atom, and this sulfur oxygen pi bond is cleaved. And in the next step, the lone pair of oxygen comes back and Cl minus expel out. So we get this intermediate, and deprotonation of this oxygen by Cl minus ion, we get the chlorosulfide compound, that is this one. And this chlorosulfide, and from this chlorosulfide, this carbon oxygen bond is cleaved, so that we get two ions, this one and this one. And very interestingly, these two ions exist as intimate ion pair, that is, they exist in very close proximity. So in the last step, this Cl minus attacks the carbocation from the same site from which the sulfur oxygen bond is cleaved. So the Cl minus ions attack from the same site, from the same face from which the carbon oxygen bond is cleaved. So this yields actually the retention of configuration product. So this is the mechanism of the reaction. This is known as nucleophilic substitution with internal return, or intramolecular nucleophilic substitution reaction. Because look at the reaction very carefully from here. This carbon oxygen bond is cleaved and the Cl minus attacks from the same site. So actually the nucleophile is present in the leaving group. So after the removal of the leaving group, the Cl minus ion of the leaving group acts as a nucleophile. So this is actually intramolecular nucleophilic attack. So sometimes it is known as intramolecular nucleophilic substitution reaction. And in the last step, the sulfur dioxide molecule is removed, so to yield the product, this one. So this is the mechanism of SNI reaction. Now the interesting part of this reaction is if we add some pyridine, some strong base like pyridine in the reaction mixture, the story is changed. If we add some pyridine in the reaction mixture, we get the inverted product, this one. So this is actually the result of SN2 reaction. So very interestingly, if we react, if we subject to react this malic acid molecule by SOCl2, we get the retention of configuration, and if we add some pyridine in the reaction mixture, we get the SN2 reaction. So now the question is, what is the role of pyridine here? If pyridine is added, the course of the reaction is changed, the mechanism of this reaction is changed. Now so in presence of pyridine, this reaction is actually SN2. Now we considered the mechanism of this reaction in presence of pyridine. Now what happened here? When malic acid molecule reacts with SOCl2, in the first step the chlorosulfite molecule is formed in the previous way as before. We get the chlorosulfite. So now if pyridine is present in the reaction mixture, now pyridine attacks this sulfur molecule and this sulfur oxygen pi bond is cleaved. So we get this sort of intermediate, this type of intermediate, right? And if now when this lone pair of oxygen comes back, the Cl- ion leaves from the substrate, and eventually this Cl- ion acts as a nucleophile, and this Cl attacked from the backside of the leaving group. So this is actually SN2 attack. This is actually SN2 attack. So Cl- ion attached to the substrate from the opposite face, from the opposite side of the leaving group. As a result of that, we get the inverted product. This is actually inversion of configuration. So this is actually SN2 reaction. Now what is the role of pyridine here? Actually, if we closely look at here, when there is no pyridine, this carbon oxygen bond was cleaved, and thus these two ions actually remains as intimate ion pair, and the Cl- attacks from the same side from which the leaving group leaves. But when pyridine is present, the nitrogen is a stronger, the pyridine molecule is a stronger base, so it attacks the sulfur atom to cleave the pi bond, and Cl- ions leaves from the substrate. So the Cl- ions actually becomes free, and this part acts as a very good leaving group. So the Cl- ion attacks from the backside of this leaving group. As a result of that, we get the inverted product, right? So so in presence of pyridine, the course of the reaction is actually changed. As a consequence, we get the inverted product. So we can sum up these two reactions. If plus malic acid is treated by SOCl2, we get the plus chlorosuccinic acid with retention of configuration via SNI reaction, and if if a plus malic acid molecule is treated with SOCl2 in presence of pyridine, we get the minus chlorosuccinic acid with inversion of configuration via SN2 reaction. So in presence of pyridine, we will get a inverted product by SN2 reaction, and in presence of only SOCl2, we get the SNI, the retention product with SNI reaction. Let us take some examples of SNI reaction. We have already discussed two examples. In this example, we have taken 1-phenyl ethanol. In this molecule, the configuration of the chiral center is S, and on treatment of this molecule by thionyl chloride, we get the chloro derivative of this compound, and of course the configuration of the chiral center remains S. So this is actually retention of configuration. So this is an example of SNI reaction. We are going forward to the next example. Here the configuration of this alcoholic molecule is R, and if we treat this molecule by thionyl chloride, we get the chloro derivative with the same configuration R. And on treatment of this molecule by thionyl chloride in presence of pyridine, we get the chloro derivative, but here the configuration is inverted. So this reaction in presence of pyridine, the reaction occurs with inversion of configuration. So this is actually SN2 reaction. We can think this reaction by flying wedge position also. The flying wedge position of this molecule is this one, and on treatment with thionyl chloride, it gives this product. If we observe very closely, we see this OH groups was below the plane, and this chlorine is also below the plane, and all the other things remain same. So the R configuration becomes R, and in presence of pyridine, the configuration is inverted. Look at here very closely. Here D was present in the above the plane bond, and here D comes to the below the plane bond, and here OH was below the plane bond and Cl exists at the above the plane bond. So the configuration is inverted. So this is the example of SN2 and SNI reaction. Now we can sum up our today's lesson. Now SNI reaction is different from SN2 and SN1 in different aspects. First of all, SN2 reaction occurs with inversion of configuration, but SNI reaction occurs with retention of configuration. So SNI is not actually SN2. And again, SN1 reaction, in SN1 reaction, we get a mixture of products, a mixture of enantiomers. But in SNI reaction, we get a single stereoisomer. So SNI reaction is not like SN2 or SN1. Now consider assertion reasoning, an assertion reasoning type problem. SNI reaction is different from SN2 and SN1. The reason is Cl minus attacks the chiral center from the site from which the OSOCl, the leaving group, leaves the substrate. We just consider this step. The Cl minus, the nucleophile, attacks the chiral carbon from the site from which the leaving group leaves the substrate. So this is actually the cause of retention of configuration. And again, in this mechanism, the ion pair is not completely dissociated. That is, no real existence of carbocation. This is very important. We just consider this sort of cyclic transition state. Take a close look here. This cleavage of this carbon-oxygen bond and the making of this carbon-chlorine bond occurred almost simultaneously. So the internal nucleophilic attack and the expulsion of sulfur dioxide molecule occurs simultaneously. So there is no real existence of carbocation. Actually, this making of this bond and breaking of this bond occurs simultaneously, almost simultaneously. So here retention of configuration occurs. So this is not actually SN1 type reaction where there is an existence of free carbocation. Now here the points to remember for SNI reaction: SNI mechanism occurs in ether medium like diethyl ether or tetrahydrofuran, etc. The reaction follows second order kinetics. That is, the rate of the reaction depends on the concentration of both the alcohol and thionyl chloride. Actually, this nucleophilic attack step, the formation of ion pair and the nucleophilic attack, which occurs simultaneously, actually this step is the rate determining step of this reaction. So, and in this step, both the alcohol and thionyl chloride molecule involved. So the rate of the reaction depends on both the concentration of alcohol and thionyl chloride. So this is all about SNI reaction, SNI mechanism. Thanks a lot. Thanks for watching the video. We will meet with another important video. Thank you.